says construct the preferred pathway for the synthesis of this with propene-derived alkyl halide and alkoxide intermediates by dragging the propane intermediate. Not every reagent given or intermediate will be used. Okay, so now if we start from here, right? Well, first of all, we know that if we want to form an unsymmetrical ether, right? If we want to form an unsymmetrical ether, right, we're going to be using this guy. We're going to be using the Williamson Ether synthesis. Now, the Williamson Ether synthesis depends on two things. It depends on creating an alkoxide ion, and it depends on creating an alkyl halide. Right? So this is why you see these two diverging pathways. The reason why you're seeing the two diverging pathways is because we need to create both of these guys so that they can interact to create the ether. So let's just try to create the alkyl halide, and we're going to want to create the alkyl halide that's going to be on the less substituted position because we want to do an SN2 reaction. So in order to do that, we're going to use HBrM peroxide, right, which is simply this right here. And then this is simply going to give us this here, right, and the hydrogen will attach here. Okay. So we've gotten the alkyl halide. Right. Okay. Actually, no, this will not be right. It'll be on this pathway.
Okay.
Peroxide. We'll generate this here. Alright. Now, so this is our alkyl halide. Now we got to generate the alkoxide. In order to do that, we need to form 1, 2, 3. We have to form an alkoxide, and we have to form an alcohol first. And in this case, it's going to be Markovnikov addition of an alcohol. So we can just do a hydration reaction. Create the Markovnikov alcohol, and we deprotonate with some base. In this case, we can use NH, and that's going to form this alkoxide. Then so this is our alkoxide, and then we're going to get an SN2 occurring between these two guys. Right? Generate this product here. Right? That's how this reaction here will occur. Alright, so in this particular problem, we have benzyl ethyl ether, which is this guy here. Right? It's going to react with concentrated aqueous HI. That's what we have here. So we're going to get some protonation occurring to form two initial organic products, A and B. Okay. Right? So this is going to react with this guy to create two products. Furthermore, reaction of B with HI produces organic product C. Draw the structures of these three products. Okay. Now, so the first thing that's going to, of course, happen is we're going to get protonation because this is an acid. Right? So we have HI. We get protonation here. Right? Once we get a protonation, we would generate this structure here. Right? Now, the idea here is this is going to be a leaving group. So you can either see it as this is the main molecule, So, 1 second here. Alright, so there's different ways we can look at this, which can lead to the generation of different products. So, if we said that this is the main molecule and that this is the leaving group, then we would generate I think they're just looking for the alcohol. So we would just use this here, this part here. We would have this OH. Right? Now, if we were looking at this one over here, and we were supposing that it was leaving this way, then we would say that this alcohol here would be formed, right? Now in this scenario here, we got to switch these around because we're going to do an SN2 reaction on this. All right. Now, the reason why we're putting this one down here as opposed to this one is because we're going to do an SN2 reaction, and an SN2 reaction is not going to occur here. An SN2 reaction will not readily occur here. Well, actually, no, it probably most likely can, but this doesn't really have a lot of steric hindrance. All right. So we're going to say that it's going to more likely occur here than over here because at this carbon center here, there's a lot of steric hindrance.
Okay.
And SN2 doesn't like to be sterically hindered.
Right.
Right? So now we can have this HI here. He's going to go ahead and protonate this guy here.
Okay.
And we're going to generate this. Then the I minus is going to be floating around in solution, and it's going to go here and do an SN2.
Okay.
It's going to generate this product here.
Okay, it's not an SN1.
It wouldn't be an SN1 in this case.